The topic we are reporting on is deep reinforcement learning in 5G and 6G wireless communication network. The team members include Li Junyan and myself, Zhu Weicheng. In the following, I will provide individual summaries for the introduction, problem formulation, and the proposed solution for each paper we present. Okay, then the first paper we introduce is EMBB and the URLLC service, multiplexing based on deep reinforcement learning in 5G and beyond. Okay, introduction. In 5G, EMBB services are defined to support high data rate, while URLLC services focus on low latency and high reliability. Multiplexing these two services on the same wireless radio frequency leads to a challenging radio resource allocation problem due to their heterogeneous requirements. And problem formulation. The problem is formulated into two optimization subproblems. Subproblem 1 aims to maximize the throughput of EMBB service by deciding ratio of radio resource and power resource allocated to each EMBB user. Subproblem 2 aims to maximize the throughput of URLC service by deciding ratio of bandwidth punctured from EMBB user by each URLC user, ratio of radio resource and the power resource allocated to each URLC user. And at the end, the proposed solution is 4DL method is applied to the environment and compare the simulation result. Hollis gradient, deep Q learning, advantage actor critic, deep deterministic policy gradient. DRL is applied to decide ratio of radio resource and power resource allocated to current EMBB user, ratio of radio resource and power resource allocated to current URLLC user, and the ratio of radio resource punctured from EMBB user. The second paper is a deep reinforcement learning based routing scheme for LEO satellite network in 5G. First, the introduction. LEO satellite network can significantly extend the wireless coverage in 6G networks. There is energy issue of LEO satellites due to the limitation in space and the lifetime of LEO satellites. There is a necessity to save the energy of LEO satellite network. Okay. And the problem formulation. The problem is formulated as a routing optimization problem, aims to minimize the energy cost of LEO satellite network by deciding the routing path of each routing event on LEO satellite network. Delay constraints should not be violated. And the proposed solution. DDPG-DRL method is applied to the environment. DRL is applied to decide the expected network. Loading matrix. According to the current network loading matrix, Dijkstra algorithm is applied to decide the path according to the expected network loading matrix. And the subpaper is deep reinforcement learning-based, mobility-aware SFC embedding for Mac in NEC in 5G and beyond. Introduction: Surface Function Chain (SFC), an ordered set of virtual network functions (VNF), enable flexible deployment and on-demand service in 5G. Multi-access edge computing (MEC) networks. The SFC embedding problem involving placement and migration. Inappropriate decision leads to failed placement of migration, affecting service downtime and end-to-end delay. Problem formulation: a problem is formulated as an SFC embedding optimization problem, aims to maximize placements and migrations service acceptance rate by deciding the MDC server location of placement and the migration of SFC. End-to-end delay constraint and service downtime constraint should not be violated. Then the paper says the proposed solution. DDPG-DRL method is applied to the environment according to a type of request, placement and migration. Placement agent and migration agent make the decision. The set of MVC where to place or migrate the request on it. Okay, then the above content constitutes our presentation, and with that we conclude our report. Thank you.